Again, as a quick summary of both of these, if we are doing addition and subtraction, we want to be in a Cartesian system. If we are doing multiplication and division, let's be in a polar system. And overall, if you are in MATLAB, it will do all of these things for you. So we'll have a follow-on video that shows how to enter all of these values in MATLAB. Again, as a large summary, these are our two coordinate systems where we have our relationships between x components of x and y, and then our polar components of r and phi. And again, our relationships on the right here that move us between the two systems. Following on from our discussion about how to do arithmetic operations, in a previous AC analysis problem, we had a quantity that was in a polar system, and we needed it to be in a rectilinear system, in a vector system. And I just told you it was negative 7.5 and negative 13. But let's see how we can actually do this conversion from one system into another. So this object right here, the two components we need to look at are the length of the vector and then the angle. So the angle here is actually negative 120 degrees. So this object is actually all the way out here in the third quadrant. So this angle right here, phi, is 120 degrees. The length of this object is 15. So we know that this point out here is at 15, or has a length of 15. And so our goal right now is to find out what is x and what is y for this particular object. And if we remember that x is equal to r times cosine phi, then we can say that it's 15 times the cosine of negative 120 degrees, and we find that our x value is, as we expect, to be negative 7.5. So that means that right here it is negative 7.5. Our y value is going to be r times sine of phi, which would be 15 times sine of negative 120 degrees, and our value is going to be negative 13. So our y coordinate right here is at negative 13. So again, when I drew this, I wrote this value right here as 120 because it is 120 degrees back, given the way that I drew the angle. But if you are punching this into your calculator, these values go in exactly like this, and the only thing you need to take care of is to make sure that your calculator or MATLAB or whatever it is in degrees mode. MATLAB by default will always be in radians, and so we'll have to convert our angle quantities, but otherwise, if you punch this into your calculator, you should get the exact results. As our final transform, let's take a Cartesian object and turn it into a polar coordinate system. So again, we have a 2D coordinate system where our x-axis is on the real number line and our y-axis is on the imaginary number line. So for our object here, this is our real component of the vector, so it's at the spot of 3. And this is our imaginary component of the vector, and so we'll be up here at 4. So this object is actually right here at 3 plus j4. Now, the things that we are interested in finding are what is the length of this vector here, and then what is actually the angle for this vector. And the length, if we recall, is always x squared plus y squared square root. So this will be the square root of 9 plus 16, which is the square root of 25, which is 5. Our angle will be the tangent inverse of y over x, which will be the tangent inverse of 4 over 3, and this value right here is 53.1 degrees. So if we were going to write this out as a polar object, this would be 5e to the j 53.1 degrees. And just like before, you can do these direct transforms from your calculator. Again, make sure that when you are doing the angles that you make sure that your result is in degrees, because we want degrees to be up here in the exponent.